How do you build a split flap display that doesn't only work, but is smart in the sense that it supports modern day connectivity, can be updated without a hot wiring mess, and scales from a few modules to whole installations? You need to focus on electronics. In this video, I'll walk you through the current design of my split flap controller board, some of the choices and thinking behind it, and how using it actually looks like. So if you're interested in that, let's go. So this is the circuit board, version 5.6. It's come a long way. A few connectors, a few components. It's honestly quite simple once you break it down. A microcontroller, a motor driver, connectors to easily plug everything in, and some electronics housekeeping. Let's walk through it. The actual brain of the brain is a small microcontroller, in this case an ESP8266. It's very affordable, comes with enough processing power, draws very little energy, and best of all, supports Wi-Fi and over-the-air updates out of the box. So it's a perfect fit for this project. A split flap module that doesn't move is pretty useless. To solve this, the board is equipped with a TMC2209 stepper driver, which is a state-of-the-art driver for stepper motors that is optimized for being very energy efficient and moving motors super quietly. Without the flaps, the motor is barely audible when it's moving. It's the single most expensive component on the board, but absolutely worth it. There's also three critical connectors. One is for the Hall sensor. The sensor detects a magnet that is installed on the main drum and detects the index position, so the board basically knows where the letter A starts in relation to that. To avoid cables, the Hall sensor sits on a separate board that plugs directly into the main PCB. So in the final installation, you really cannot see it and you don't need an extra cable. The other two connections are for daisy chaining. Each module talks to its neighboring modules using small connector boards, and the in and out connections are for connecting those. There's a separate video explaining that linked below here. There's also some additional electronics for power management, stepping down the 12 volts that power the board to what the ESP and the TMC need, a fuse, reverse polarity protection, and some connectors for when over-the-air updates actually don't cut it. So you actually also have the chance to manually upload a better firmware if you think that is needed. All right, enough with the theory. Let's actually power up a module and go through the first use flow from beginning to end. So the first thing that we are going to do here is obviously pull the module out of focus and then add one of the connector / injector boards. You can see the ESP powering up with that quick blue flashing light. And what we're going to do then is connect to the created ad hoc network. So it's just spinning up a network. If it hasn't been set up before, you can connect to that. And then you move over to splitflap.local in your browser. There's really not much more to it, and you'll be able to actually interact with it. The first thing we are going to do is to just make it blink. Like there's a blink all, and you can use it. You tap on it, you're blinking the display. And what we're doing now is we're going to home it. That means we're teaching it where its zero position is. So I'm tapping the start smart homing here with the target of this display. And it's just rattling through. And the only thing that I have to do now at this point is to select which letter I'm seeing. So now it's D, so I tap D. Then it's R, so select R. And then it's 4, so select 4. And that's all there is to it. There's kind of like not more that I have to do. And at this point, I can just select random characters to be shown. So just going through a few of them, also different speeds. So obviously I can also change the speed at which the display is moving to the next character. And I'm not gonna lie, it's actually fun to play around with it. Enjoy the sound. But let's be honest, a single split flap display is a bit boring, so what we're going to do is just add a second one to the mix. Again, struggling here a bit with the focus, still trying to get a better handle at this YouTube thing. So we're connecting it using the other side of the injector board really. So you could see the quick blue power up flash. And there's nothing we need to change now. So the browser stays connected to the first module. And what we're again doing is we make them blink to just quickly confirm that it's all working. And then we're just going to quickly home the second display. So the second display, it's a bit counterintuitive, but the second display is now on the right. And we're going through the exact same flow again to just make sure they're both quite literally on the same page. So I'm again confirming which letters I'm seeing. And you might wonder why I'm always tapping the same letters. Yep, that's true, but still it's quite important because the first homing, the first signal of finding a magnet is very precise. So we're just making sure they're always both completely aligned. And now I can actually just send the both modules commands at the same time, which is obviously fun. And this rattling sound actually concludes this video. I wanted to show you what the brain of the flip forward split flap module is actually made of, how to connect to it, how to interact with it. And in the next one, I'm going to walk you through the protocol design. So if you care about that, subscribe so you get notified when that one launches. Thanks for watching.